powerlifter and you want a new challenge.
Well, today, DBAC has partnered with the stars of Physics 1A03, Physics 1 Einstein to bring you the Accel-it. More like Excel, you rate it.
Call 1-800-PHYS-6 today for a free trial.
Are you up for the challenge?
Shamita, I think that's our first caller.
I'm ready to excel it!
All right, let's get started. Here I go.
Are you sure this thing's on?
I think it's working. It is. It's okay. It's working okay. Yeah.
It's a little rusty, guys.
All right, buddy. I think you got it. You keep going. Yep. Push through.
Woo! Yeah.
We're rooting for you. Oh, there you go.
Look at
him.
that.
Look at him
the
go.
flex.
Oh, yes. How about we pack it up now? Come meet us on the couch and you can tell us a little bit about your experience before we send you home.
That was easy. Barely even broke a sweat.
So, tell us about your experience.
Well, it was quite a challenge at first, but I did it. I'm really into that bulking scene, always making those gains. You can catch me at DBAC, ladies.
That's nice.
I definitely know that worked. But I am curious, how much did I actually lift?
Well, let's calculate this.
Before we go calculating what this tough guy over here benched, we have to understand exactly what a force is. In the scope of this course, we've defined a force as an interaction between any objects. In our particular example, there is an interaction between our gym man and the machine that we've built. However, in order to calculate the mass that our gym man is benching, we have to look at our machine as a system in and of itself. We must note that the sum of forces acting on a system is equal to the sum of forces in the x direction plus the sum of forces in the y direction. Now, there is one force acting in the x direction, and that is the force of tension. There are two forces acting in the y direction, and that is the force of tension and the force of gravity. Now, you may notice that tension acts in both directions, and this is because there is a tension force applied by the rope at an angle. In our example, we measured this angle to be 68 degrees. Whenever there is a force applied at an angle that is not parallel to our coordinate system, we break it into its respective x and y components. In our example, the force of tension applied on the rope is given to us. We decided that in our system, we want the gym man or whoever is using our machine to be able to set the tension to whatever they want. Our gym man chose 15 newtons as the tension that he wanted to use. We will set our coordinate system as up as the positive y direction and to the right as the positive x direction. So we have assessed two things: what forces are acting on our system and in what direction they are acting.
Well, now we have drawn out our free body diagram, and so now to figure out and solve our mystery weight, we realized that we don't need the x component or anything in the x direction because what we're trying to solve is acting on the y direction. Now, in the y direction, we have the y component of tension acting on the mass as well as gravity. Now, the y component of tension we solved as t sine 68 degrees, which was derived from primary trig ratios. So also, because of this, we found the force of gravity, which is mass times gravity, and in order to solve for this, we're going to isolate for m, which is mass, and we're going to do that in kilograms. Now, because the force of gravity is in the opposite direction from our positive direction, we know that the gravity is going to be negative, meaning it's going to be the y component of tension minus the force of gravity in order to solve. our mystery weight. Now when we do all the math for it, our final equation would be mass is equal to the tension sine 68 over gravity, which would be 15 sine 68 degrees over negative 9.8, giving us the final weight or the mass of 1.37 or 1.4 kilograms.
Good job, Shamita.
Hey Shamita.
Hey Rhea.
Talk about forces in action, eh?